Hello boys and girls, welcome to Mrs. Spandu's Math Movies. This section is 5-3 for Algebra 1, Function, Rules, Tables, and Graphs. So our objective is to model functions using rules, tables, and graphs. Okay, so first off, we have a couple of definitions. Our first one being the independent variable. And an independent variable is a variable that provides the input values of a function. Okay, oftentimes these are the x values or the also known as the domain. And a dependent variable is a variable that provides the output values of a function. Okay, so these are often the y values or the f of x values, so to speak. Also, these would be the range of data. Okay, so here we go. So let's look at this. 3 views of a function. Okay. At the local video store, you can rent a video game for $3. It costs you $5 a month to operate your video game player. The total monthly cost, C of V, depends upon the number of video games V that you rent. So use the function rule C of V equals 5 plus 3V to make the table of values and a graph. So we have 2 things we want to do here. So first of all, they've given us, if you rent no videos, you rent 1 video, or you rent 2. Okay, so C at 0, C of 0, gives me a value of 5. So then my ordered pair is 0, 5. Okay. C of 1 gives me 3 times 1 is 3, plus 5 is 8, so my ordered pair would be 1, 8. Also, the V values might be thought of as those charted along the horizontal axis. The C of V would be the vertical axis. As you can see, we don't have x and y in this particular function. And finally, when V is 2, 3 times 2 is 6, plus 5 is 11, so the ordered pair is 2, 11. Okay, so now what we want to do here is go ahead and plot these ordered pairs. So 0, 5. Now in this case, we probably wouldn't be graphing down here because you can't rent a negative number of video games. Although theoretically that line does exist, it's not a value that fits this function. Okay, and 1, 8. And the third one is 2, 11. So 2, 11. Okay. Then what you want to do is take a straight edge, which of course I forgot to bring with, so I'm going to use the CD case because that's what I have here. That has a straight edge. And I'm going to connect. Okay. So basically, as the number of video games increases, the cost of renting, not games, but videos, the cost for the rent is going to increase as well. Okay, here is a quick check. Right now or later, your choice. I'm going on to example number 2, graphing functions. Make a table of values and graph the function y equals the absolute value of x plus 2. Okay, So here we've chosen -3, -1, 0, 1, and 3. And I'm going to substitute those in and see what I get. So -3. So the absolute value of -3 is 3 plus 2 is 5. So my ordered pair is -3, 5. When x is -1, the absolute value of -1 is 1 plus 2. 1 plus 2 is 3. So -1, 3 is another ordered pair. The absolute value of 0 is 0 plus 2 is 2. So 0, 2 is the third ordered pair. The absolute value of 1 is 1 plus 2 is 3. So 1, 3. And 3. The absolute value of 3 is 3 plus 2 is 5. So my ordered pair on that is 3, 5. Okay, so now let's go ahead and plot these. So we have -3, 5. So 1, 2, 3, 1, 2, 3, 4, 5. -1, 3. So -1, 1, 2, 3. 0, 2, 0, 1, 2. 1, 3. And 3, 5. So 3, 5. Okay, back to your straight edge, trusty CD case in this case. Leanne Rhymes, how about that? Okay, so in this case I see that these are going to be, okay, I wrote a little bit on there so it's not pretty and straight like it should be, but okay. We see our graph looks like a giant V, basically. Each width, it reflects basically over the y-axis. Notice that this point is a reflection of that one, this one is a reflection of that one. Okay, so this is what you're going to find with absolute value equations. And generally on these, we're probably going to want to graph about 5 at least points, so that you can actually see the graph appearing and understand what it's going to look like. Okay. All right, let's move on to this one. Similar, but you're going to find that the graphs to these two are going to seem like they're going to be very much the same, and they are going to be somewhat similar, but this gives you another unique type of graph. So our function is f of x equals x squared plus 2, and our values are -2, -1, 0, 1, and 2. So again, we want to use 5 values in here. So f of -2 would be x squared, which is 4, plus 2, which is 6. So the ordered pair is 2, 6. F of -1 squared is 1, plus 2 is 3. So -1, 3. F of 0 squared is 0, plus 2 is 2. So 0, 2. Excuse me. F of 1 squared is 1, plus 2 is 3. So 1, 3. And F at 2 squared is 4, plus 2 is 6. So 2, 6. Looks very similar to this set of ordered pairs as well. Let's see what happens though when we graph, and you're going to find this to be a little bit different. So -2, 6. So -2, 2, 4, 6 will be right up here. -1, 3, -1, 1, 2, 3, 0, 2, 1, 3, and 2, 6. Okay, when you take your straight edge, though, you're going to find that these are not linear, okay? I can get 2 of the points, but not all 3. We have, this gives us a parabola, this type of graph, all right? It is also symmetric around or over the horizontal, the vertical axis, the y-axis. And we see again that these lines are symmetric. They are just not linear. Neither side is a linear function, okay? So they are, each one of these, this up here and this down here, are functions, neither one is actually linear, but no part of this one is linear, where at least half of this one is linear. So they look like they're going to be the same till you get down to that nitty-gritty of using that straight edge like we talked about in class and seeing how they do in fact connect. Okay, a couple of more, just 2 quick checks on this all together. This one has 2 parts. So have those 3 done and completed for the next time we meet in class. Bring in any questions you might think of